This is Pourdanis. I'm really happy whenever I have guys that used to be here presenting talks. So it was used to be one of you, and now he's here giving talks. And I know that he's invested a lot in testing and learning about testing, and I think you're a practicing testing engineer, right? So let's hear.
So before we start, sorry Martin and this guy, I think that you listen to English, right? I will do a brief introduction in Greek because I was not prepared to have a English presentation, but it's no problem. Λοιπόν, θα σας πω κάποια πράγματα. Είμαι πάρα πολύ χαρούμενος βασικά που είμαι εδώ πέρα μετά από πολλά χρόνια, φοιτητής και εγώ του ΤΕΙΣΕΡΟΝ. Εκτιμώ πάρα πολύ το έργο που κάνει ο κ. Πεταλίδης, γιατί μπορείτε να το καταλάβετε οι περισσότεροι, αν είστε φοιτητές που περισσότεροι είστε, μπορείτε να καταλάβετε μετά όταν τελειώσετε τη σχολή, όχι τώρα. Τώρα είναι τα μαθήματα, είναι τυχιακές, είναι όλα αυτά. Το έργο θα το καταλάβετε μετά και θα με θυμηθείτε, πιστεύω. Οπότε, αυτό το site, σε αυτό το slide σας δείχνω την πρώτη μου παρουσίαση που αναγνωρίζετε που είναι αυτό. Είναι το αμφιθέατρο του ΤΕΙ. Ήταν πριν 8 ή 9 χρόνια, πιστεύω, εδώ. Πού είναι ο Χρήστος? Να, ο Χρήστος. Το 2012. Ωραία, πριν 8 χρόνια. Λοιπόν, 2012. Ήταν το 2000. Οκ, εντάξει, πριν 7 χρόνια, sorry. Λοιπόν, όταν εγώ και ο Χρήστος είχαμε μια συνεργασία να δημιουργήσουμε ένα community εδώ στις Σέρρες που θα ασχολιόμασταν με τέτοια πράγματα, να κάνουμε παρουσιάσεις κτλ. Πήγε πολύ καλά, όπως βλέπετε. Περάσαμε πολύ ωραία. Τελειώσαμε σαν φοιτητές και ξεκινήσαμε τη δουλειά. Αυτό που μένει όμως είναι ότι αυτό είναι το πρώτο μου talk και αυτό είναι το πρώτο μου talk πριν ακόμα κάνω την παρουσίαση της πτυχιακής μου. Οπότε με βοήθησε κιόλας να κάνω και τις παρουσιάσεις μετέπειτα και στην πτυχιακή μου και πλέον σαν διοργανωτής του Software Testing and QA Meetup στη Θεσσαλονίκη κάνω κάποια presentation, με έχουν βοηθήσει πολύ και εμένα και γενικά βοηθάνε τον κόσμο που ασχολείται με το community. Okay, so because we have Martin and the guy there, I don't know your name. Your name? Okay, Burak. The presentation will be in English. Sorry for any faults on grammatically things or for anything that I will forgot, but it's okay. So, my presentation here today is for Agile testing practices. First of all, we need to specify each word of presentation. First is Agile, second is testing, and third is practices. So, first we will talk for Agile. Agile came with a really interesting problem that came up through the decades of software development. The same as if your professional gives you some kind of exercise to do with the semester. So to the end of semester, you need to give a project that's work and all of this stuff after 6 months, you know. Think about it, this will be in a place of years. So you get the specifications of a project, you work on that, you work, and one day after 2 years, you release it. So this kind of work in the start of the beginning of software development seems to work, but the things change now, and all things go faster. So we need to try to think some other way of software development. So some guys from really software developers sit down and think the agile way of software development. And in some words, what it is, we have some kind of sprints. The sprints are 2 or 3 weeks that we develop the project incrementally. So we start from the login, and then we give something to work in the login. We give it to our clients, and we get feedback, and this kind of loop that. So as you saw in the video, the problem is common. We are not so good to estimate the software projects because something always will go wrong. And this is the traditional way, the waterfall model, right? Design, program, test, release. The Agile model says that all are cycles, right? Design, program, test, release. And this kind of cycles will be, like the time frame will be 2-3 weeks, I don't know. It's based off organization and all of this stuff. But after we adopt the Agile, we redesign the reality-based is something like that. So it's not like a circle. It's kind of, we go from release to program, we go from design to test, and there is a black hole for unresolved issues. Those unresolved issues stay there and wait. If we don't handle the Agile process correctly, this black hole of unresolved issues will go bigger, and then take us inside, and will be kind of have the famous technical debt. So as you see, those statistics say that 87% of Agile teams starts with technical debt in some form. What is technical debt? Technical debt is some kind of working with old infrastructure of code, or work with legacy data sources, or with legacy functionality, with not correct design and all of the stuff, and try to pay this technical debt. The statistics say that only 22% are paid both the legacy data sources or the functional data and the functional data debt, technical debt. This kind of stuff, if you are a new guy in a software development industry, you will see that if you are working in a banking project, for example, banking projects are created before 20 years, and you will face these problems. All of this. Legacy data sources, legacy functionality that need to be refactored. So you need to be very focused and very, let's say, patient with all of this to pay this technical debt that exists, and this is your job, right? It's not only the fuzzy way with the new functionality and latest frameworks and core features and all of this stuff that we like to work. So one kind of methodologies that we follow is Scrum. Did he see this? Yeah, you know that? You need to do, if you don't know, Silicon Valley is a kind of series or TV series. I really recommend you to see that. It's very funny. So the Scrum, as we say, it fits your team. My past experience say that I'm in the industry about 6 years now, 5-6 years, that the Agile doesn't work for all. Because if you are a small team, the change of mindset of Agile and change of how you will work, not like you get some project manager come and give you all the specifications and say goodbye, and he will come after 6 months and he wants the project finished. So this change of mindset needs to change to all organizations, not only to the development team, not only to the testing team, not only to the whole, not only to a part team of any organization. It needs to fit to the whole people that interacts with a product or something like we sell something. If you work in a company, anything else we sell. So maybe it works for a small teams also, because the adoption of Agile, it's really hard to apply to many people. You know, if it's a development team with 10 people, we can sit down and say, this is good, okay, let's try this. But in 100 people, it's not so easy, right? So one of the practices of Agile testing also that comes to the Agile testing, we go to the second word of our presentation. It's kind of, it's called three amigos, the three friends that sit down to a table, and one from the business domain, one from the development domain, and one from the testing domain. And for each feature, they reply to 3 simple questions. The business reply what problem I'll try to solve, right? The development team, the development guy replies how you might will build a solution to solve that problem. And the testing, what about this? What possibly can happen? And from this kind of procedure, this kind of procedures create to be all in the same mindset. So all in the same shape, let's say. The business know what the developer will do and what the tester do. The tester know what the business wants, so what to test, right? And all of this kind of stuff create what kind of, we say in Agile, user stories. So let's say we have a user, and as a user I want to log in and press this button and do that and do else and do something. And the development try to think how to build this, and the tester how to test it. And one more specific practice on the Agile world, it's shift-left testing. Shift-left testing is it's the first, with the previous slide, as you see. The testing starts from early beginning of the analysis of a feature. So we don't have any code, right? We do a discussion with us, with each other, and we all agree of what we deliver. The business what you get, and the development what to deliver, and the testing what to test. So the shift-left testing injects the testing to the whole development life cycle. From the very beginning, from the design, from sit down next to the shift-left word come from that the tester sits next to developer and they work together. They do like pair programming. Not how to implement this, but to help him to understand what exactly needs to verify, and if he changes one kind of service. Yes. One kind of service, maybe this affected to another part of application and all of this stuff. Also, the statistics say that 45 to 65% of defects are introduced to requirements. So if we have clear requirements and we do a clear analysis before even we start to write any line of code, we will eliminate 45 and 65% of defects. That's yeah, yeah. It's kind of a myth, right? But if happened, I saw that happened, it really see the results after all. But this requires time, and as I said before, the Agile needs the adoption of all kinds of people that interact with the project, right? And most of them that interact, they are from the business side. It's not so easy to convince them to adopt this kind of methodology. So we see there are requirements, architecture, and design activities. This kind of activities, requirements, architecture, and design, doesn't have inside of them any line of code. So think about that. All of testers work closely with developers as a team. So the testers are not the bad guys that find bugs and makes developers angry or something like that. We are in the same mindset that we have a common goal, right? To go home, sleep, and go next day to the work. Not even to call the project manager and say this doesn't work, why this happened, and all of this stuff. So the development team, it doesn't something different with a testing team. We have the same goal. Each of them sees the project, sees his work from the other state of mind. The developer from the design level and architectural level, and the testing team from the domain level, and most of kind of stuff with interaction with the system and testing architecture, and most common that we will see. So the Agile roles inside the team means Agile skill set. So the software development, why we need this? The first thing is why we need this. The software development companies doesn't need only developers. We need testers too, right? And we need guys from the business side. I will recommend you, because there is a trend, so if you are in kind of studies like informatics, like we are here, all need to be developers. This is a false for me. I tried development for 3 years, and then I became a tester. So the industry will show you the way. So it's not like let's say a shame to be a developer and then choose a different career path and to be a tester. It's just you fill your skill set to the industry. If you are good to software development, it's good to go. If you are good to testing, it's good to go. If you are good to networks, it's good to go. If you are good to database, if you are good to security, it's good to go. There are so many kind of career and paths to the software industry that I don't think that someone here doesn't have something, a skill set that will fit in the industry. You just need to find it and involve it, right? So
even that might be more refined to the business life.
Yeah.
Scrum Master.
Yeah. So as you see, the model of Agile roles have something like we say cross-functional team. The cross-functional team is what inspired me to be a tester. So I work in a team in about 10 people, right? And we have, I started there as software developer. So we are about 4 developers, 1 Scrum Master, 3 testers, and 1 product owner. A small team that creates features and all this stuff. So one day, Scrum Master came and say, we will try cross-functional. What? Okay. What's for cross-functional? Cross-functional means that for next month, you, as software developer, as software developer, will be tester. Will be kind of tester. Let's say okay, and the team say okay. Let's try this. Why not? And when I became a tester for a month, all the team recognized my effort, and I really like it, how the testing process go. And Scrum Master say, you are good to testing. Why you don't like choose this career path? And this also, think about it, avoiding people to getting bored. If you are in a software development industry that does web application, for example, you will do APIs, Spring, Java, and after many years, here Achilles can confirm it, after many years, you will bored to do APIs, right? You will bored by doing something that you have already done, but it's just a simple renaming of that. Or you will add the API for contacts, and then you will do an API for employees with the same model, but it's just different crude functions. Something like that. So this kind of T-shaped skilled persons are in the model of Agile, the T-shaped Agile team, the most, let's say, the most imaginary in a good way. It's all the people inside the team have one kind of a skill of the other. So the business analyst, that's the third person of the business, have a core functionality to analysis of the business, but know something about testing and know something about the development. Because the main gap that exists besides the business and the development is always say, you are a business analyst, you don't know nothing about code, right? Or you are a tester, you don't know nothing about code, even more. So the most of T-shaped persons you have, the most productive is the team. That's the side, because all people know something. They have a core skill that is analysis, development, and testing, but know something about what the other guys in the team do. So now we will say on the testing process of because okay, Agile is this, and we will focus on testing right now. So testing is a way to avoiding bugs, right? But bugs is a physical thing, as Dijkstra said. If the debugging process is removing software bugs, the programming must be the process putting them. So it's a common thing. It's not something that they don't exist. We need to accept this. There is no, if a human interacts with a software, it will create bugs. Even is a top skill set guy, because from inside of your head or your mind, you cannot think, it's impossible to think all the scenarios and interact with the code when you build in the infrastructure and all this stuff with all variables and probabilities and this kind of stuff. So it's a common thing. Let's say that we accept that and move forward. So let's see how much the bugs cost to an industry. So in 2002, a study says that 59 billion in the US kind of industry annually cost the bugs to the industries of software companies that work in software products. This kind of number is too big, right? In 2002. But if we go to 2016, it's $1.1 trillion. And this cost come from not from people that work on resolve bugs. This kind of number come with customers that are not satisfied and leave the company because the product has many bugs. It's not usable. So we need to rethink how we can solve this problem if we work in an industry like that. And the statistics say that if a cost found on the design, it costs about $4 because we don't have any code. Without thinking about that, we designed the feature and we find it costs $4 working hours, let's say. If we find it through the code, it costs $10. If we find it by a unit test, because someone needs to write the unit test, right? It's about $24. In found in the integration test, we need a dedicated tester that wrote integration test and costs his salary, I think, maybe. But if found by customer, after product ship, it costs $6,000. So if we find the bug earlier, it costs the least for our company. Let's analyze how an issue and bug can produce. Think about we have a line that many things interact on them, and the output is a defect. So we have the tools, the programming language. Let's say the defect maybe is a security, because I will connect with the previous presentation. The defect maybe is a security issue, let's say, and we work in a JVM old version that has the security issue, and the defect goes right there. We have the methods, the improper algorithm. So the guy that writes the code maybe has done wrong, or maybe the algorithms that try to solve is not correct and creates a defect. And we have the input, the incorrect specification, as we say. If the analysis that we do is not correct, we give something that's not a defect, but it's not acceptable by the business. And we have the people here, a developer without experience that writes the code and creates issues. But the main thing is most developers doesn't work because as I said, it's a physical process to create issues. And most developers, because they own their code, right? It's like their baby, it's like their baby. Mothers doesn't like to say their sons or their daughters do wrong or is something wrong with them. So they call them features. There is no bug in their codes. Let's see also how from the requirement process, say types of error and defect. There is a difference, if you know, there is a difference of error and defect. So see this kind of pipeline, let's say. We have the correct requirement, design to meet requirement, build to meet the design, product source accessibility. That's the happy path, right? The second way, the second requirement is the correct design to meet the requirement, but mistakes come to the build when we build it. And the product has bugs in it. We need to correct. It's the correctable defects that we call. So the mistakes that call to a build, on the output we have something different from this one. In the third case, we have the correct requirement, mistake made by design. The shape is different.